So welcome to my YouTube channel. So here we are going with the data structure series. So in this video we'll see the graph representation. So we can represent our graph by using the two ways, that is the adjacency matrix and adjacency list. So the adjacency matrix is a sequential representation and it's used to represent which nodes are adjacent to each other and is there any edges connecting nodes to the graph. So basically this representation requires the construction of the n-by-n matrix. Okay, so if there is an edge from vertices I to vertices j, then the corresponding element of that particular matrix A, if suppose there is a edge between A and means there is an edge between I and j, then that matrix value will be 1, otherwise it will be 0. So let's consider these two examples of undirected and directed graph. So first we'll see the undirected graph. So as you can see that there is an edge in between A to B. So so at the point for means at the location of A to B, there means we are mentioning 1 here, and in again there is a node from A to D. Okay, so again we are mentioning one for this position. Then again there is edge for A to C. Then again we are mentioning 1 here, and the edge which is not present from point A, then we are mentioning 0 over there. Okay, so it's simply a matrix. It means we need to form the matrix. Okay, so and we need to put the values 1 or 0 according to the edges availability. Okay. So in this way we have done this undirected graph. Then directed graph. Directed graph means as a as a name suggests, the graph which are having the direction is called as directed graph. Means we need to follow the direction here. Okay, so the edge means A and B having the edge in between. So here we mention the one over here. Then again the A to C having the one more edge, so we are mentioning one here, but you can see here the 1 and D having the edge in between. Okay, but uh, look at the direction. Okay, the direction of the edge is toward A, not to D. Okay, so we are mentioning 0 over here. So this is the difference between undirected and directed graph. Now let's see the adjacency list. So adjacency list is a linked list representation. So in this representation, for each vertex in the graph, we maintain the list of its neighbor. It means every vertex of the graph contains a list of its adjacent vertices. So as in the example for the directed graph using linked list, so for adjacency list, we are dealing with the single linked list. Okay, so we have already done the single linked list in my previous videos. So I'm not going to explain more on the single linked list. So we'll directly move on the adjacency list. So here the head node, we need to define the each and every node as a head node, and again we need to just link their adjacent node. Okay, so as you can see that the adjacent node for the A is B and C, as it is directed graph. If suppose if suppose these graph means if suppose this is not the directed, then we can say that adjacent node for this A is B, C and D as well. But as it is directed, then we cannot say that D is directed, because that's it, because the direction for that particular direction from the direction of the edge A to D is toward A. So we cannot consider these D as the adjacent for this A. Okay, so we need to just connect the adjacent node in this adjacency list. Thanks for watching.